So in the Passport to Advanced Math, you're going to see problems that are more Algebra 2 content area. So you will see things like quadratics, you'll see things like rational expressions, imaginary numbers. So for those of you that maybe are currently in Algebra 2, this is material that you'll be learning this year. So we are looking at quadratic equations today, and a quadratic equation is just a polynomial that has a highest exponent of 2, so an x squared, for example. You're going to solve quadratic equations by factoring, so you'll set it equal to 0, eliminate any common factors, and then you will factor, which is really just the reverse distributive property. And then once you've done that, you can set each factor or each set of parentheses equal to 0 to solve. So here are some examples. The first one is already in factored form. So when you have something like this, all you do is set those factors equal to 0 and solve. So you get p equals 3 and p equals 4. This next one, we want to write it in standard form first. So that means our exponents are in decreasing order. So 5n squared minus 25n plus 20 equals 0. We have a common factor here of 5, so we're going to pull that out. That'll leave us with n squared minus 5n plus 4. Then we want to use the reverse distributive property. N times n gives us n squared. 4 times 1 will multiply to give us 4. And our outside and inside terms will be a negative 1n and a negative 4n, which give us a negative 5n. So then set those parentheses equal to 0, just like we did in the first one. We get n equals 4 and n equals 1. This last one here is a little trickier. We are going to add the 2x to its like term over here and subtract the 3 from its like term. So you've got 2x squared minus 11x minus 21 equals 0. So this one, we have to do a little bit more trial and error because we don't have a greatest common factor like we did in number 2. That 2x squared is going to come from 2x times x. And then our 21, we have to think about our options. We have a 7 times 3, we have a 1 times 21. We have to figure out which pair and in which place will give us a negative 11x from the outside and inside terms. So if I put a 7 here and a 3 here, my outside terms are 14, my inside terms are 3. If I have a negative 14 and a positive 3, those will combine to give me a negative 11. So then 2x plus 3 equals 0. We subtract the 3 and divide by 2 to get negative 3 halves. X minus 7 equals 0 is going to give us x equals 7. You also have special product patterns. So we have the difference of two squares here where it's a perfect square minus a perfect square. That's always going to factor into the square root of each term. So 3x and 3x, 2 and 2. One will be positive, one will be negative. Over here, same thing. We've got a perfect square and a perfect square. Whoops. P and 3. One positive, one negative. And then over here, these aren't perfect squares, but we do have a common factor. So we can take from 125 and from 320, we can take out a 5. We can also take out a b from both terms. So that will give us a 25u squared minus 320 divided by 5, that's going to give us 64. And then we took the b out as well, so v squared. And then the square root of each, 1 positive, 1 negative. When you go to solve, you might see questions that say how many distinct or how many unique solutions. Those two terms are interchangeable. Does a quadratic have? So here, x minus 7 and x minus 7, this is in factored form, but both factors give us x equals 7. So it's only one, unique solution. And then for some of our other equations that you're going to see today, you're going to come up with or see formulas and then just be solving formulas for different variables. So here we want to solve the formula for the radius, and they give us some other values. So the volume is 45, 1/3 times pi r squared, and they give us the height is 2. And so we can kind of put this together here. This pi is really pi over 1. This 2 is really 2 over 1. So to just clean up that right-hand side a little bit, numerically or numerator-wise, you have a 1, a pi, and a 2. So that's really 2 pi. In the denominator, you have a 3, and then an r squared. To get rid of a fraction, you multiply by the reciprocal. So we can do 3 over 2 pi, and then over here, 3 over 2 pi as well. So when we do that, on the left-hand side, this is a 45 over 1. So I can take 45 times 3 and get 135. Keep the pi. Oh, the pi was in the denominator. 135 up top. On the bottom, we have a 2 pi. That's equal to r squared. And then to get rid of the squared, you take the square root. So square root of 135 over 2 pi is equal to r. So the first thing you should do in situations like this is plug the numbers in and then solve for the variable that's left. So your assignment for today on Khan Academy is solving quadratic equations and interpreting nonlinear expressions. These are both located under the Passport to Advanced Math section, so you'll scroll down a little bit past where we've currently been working.